Hello everyone, welcome back. In our last lesson, we learned about atoms, elements, and periodic tables. We learned that elements are like pure substances made up of only one type of atoms, right? So, in this session, we are gonna learn more about what happens when elements are going to combine, right? How the compounds and mixtures are going to get formed. We'll talk about the naming conventions and creating the chemical names of the compounds. So as we talk about the chemical bonding to form a compound and mixing elements to form a mixture, we will even talk about the separation methods for compounds and mixture, right? So what we are going to focus on today is what is compound, its properties. We'll talk about naming compounds and then separation methods for compounds into its original elements. We'll talk about mixtures and then separating methods for mixtures as well. All right, so let's get started and have a brief on first understanding what is a compound. So as the name suggests, it's talk about something combining together, right? So basically a compound is a substance which forms when two or more elements are bonding or joining together chemically. All right, so the key thing over here is two or more elements joining chemically. That is going to form a compound, right? So the chemical term, when two different type of atoms join together, we call it as bonding. So that's why compounds are being formed when two elements, right? And each element is of its own particular atom, right? So when two different elements are joining, basically two different type of atoms are joining or bonding together to form a compound. All right, so here are some examples of compound. We have water, right? Now water goes by H2O as its chemical name. This indicates that water is a compound which is created or formed by the bonding of hydrogen and oxygen atom. Similarly, you have carbon dioxide. So it indicates carbon and oxygen are the base two elements which are bonding together to form carbon dioxide. Similarly, sodium and chlorine, which are two separate elements, they are gonna bond chemically to form a new substance, that is the compound sodium chloride. All right. So key thing to remember, compound is formed when two elements are joining chemically. All right. Now elements in compound are going to be difficult to separate, as we will talk further about the separation methods. Elements in compounds are going to be a little difficult to separate because they are chemically bonded. The separation is not going to be easy, just like physical methods like filtration, right? We'll talk more about it in the upcoming slides. Let's talk about the properties of elements and compounds. So now properties of elements. Why we are talking about elements? Because to form a compound, you should first know what is the element, and then when multiple elements are combined together, we are going to get the compound created. All right. So first and foremost, the base, the parent item is element. So an element contains only one type of atom. They are pure substances. They have their own melting and boiling point. So these are the properties of the element, right? So they would be pure substances, as in made up of only one type of atom. So they have their individual melting and boiling points, right? And they cannot be broken into simpler substances chemically, right? Because they are made up of only one type of atom, so they cannot be broken further into simpler substances. Examples for pure elements are gold, oxygen, or carbon, for that sake, right? Now think of the properties for compounds. Now compounds is a combination of two different elements. All right. So what would be compounds? Compounds are obviously going to have a fixed composition. When I say fixed composition, it is the combination of two different elements into a given proportion, right? We will have a new physical and chemical properties owned by this compound. All right. So as two different elements are combining together and a new substance is being formed, that new substance, that is the compound, will have its own physical and chemical properties. They may not inherit everything which is from the original two elements which combine together, right? And compounds, as they are going to form by the chemical bonding, they are going to be difficult to separate back into their original elements. Compounds can exist in solid, liquids, or gases. Some common examples of compounds are like sodium and chlorine joining together to form sodium chloride. Right, this is the most common and typical example we end up using throughout the chemistry, various chemical processes, and when we talk about the chemical bonding and the chemical names. Right, so sodium is an individual element having its own property. Chlorine is an individual element having its own properties, but when these two substances combine together to form a compound, that compound is named as sodium chloride. And sodium chloride is going to have its own physical and chemical properties which are going to be different than the parent elements, individual sodium and chlorine. All right, so that's about compound properties. Now let's say how we are going to name these compounds. So in our last lesson we talked about every element is going to have a unique name given, right? A short form given, let's say, for that particular element. We talked about the chemical names. Now, when a compound is going to get formed by joining two elements, we need to have some naming conventions and rules for compound as well. All right, so there are three main rules for naming a compound. So now, if a compound is having a metal in it, right? Let's say two elements are formed, two elements, let's say sodium and chlorine are being combined together to form sodium chloride, right? So if it contains a metal, now sodium is a metal, right? So the metal name comes first, and then we have the non-metal or the group as second. All right, so that's why whenever sodium and chlorine are bonded together, we form sodium chloride, and the chemical name of sodium chloride is formed by the metal name first. So what is Na? Na is the chemical name for sodium, and Cl is the chemical name for chlorine, right? So now NaCl becomes the chemical name of compound sodium chloride. Okay, now let's say if your compound contains a non-metal, the name of the non-metal is added with the IDE, right? Let's stick to the example of sodium and chlorine combining together. So you have sodium as metal, chlorine is non-metal. Chlorine is gonna form the second part of the name, right? Because it's a non-metal, and the non-metal name is added with a dot IDE thing, right? So that's why we see while naming the compound sodium chloride, we have sodium, the metal name as is. Chlorine name is added with IDE, forming a chloride, right? So that's why the name of the compound is sodium chloride. Some compounds contain oxygens, right? So these compounds are often have names ending with 8, like sodium nitrate, right? So if any compound being formed and there's one element which is oxygen, in that case we would have the chemical name of the compound ending with ATE, right? For example, sodium nitrate, which is having your sodium, nitrogen and oxygen, right? So this element has oxygen into it, so we made it like sodium nitrate, nit NITR, let's say, for your nitrogen, and ATE is added at the end, indicating that the compound holds one element which is oxygen. All right, so these are the three main rules. An important tip for forming a proper name or identifying a name of the compound correctly is that the second part of the compound name, that is often gonna end with either an IDE, okay, or 8, or 8. So when IDE is gonna be at the end of the compound name, it usually indicates that the compound does not have oxygen into it. Okay, usually no oxygen would be chloride or oxide or sulfide. Correct. When it comes for ATE, a compound name ending with 8, it usually contains the oxygen. So the examples here would be nitrate or sulfates or carbonates, right? So these two are going to be the important things to remember when you are to identify or write a correct name of the compound based on what elements are there in that compound. Okay, now let's talk about processes to separate the compounds back into their original elements. So as we discussed, compounds are formed by the chemical bonding between two elements. So two elements are gonna chemically react and form a new bond, creating a new substance, that is compound. So this involves a chemical process. All right. Now, as compound is created by a chemical process, even to separate out the basic elements from the compound, we need to use chemical processes only. All right. So there were three typical chemical processes which are being used to separate the elements from the compound. First one is heating, which is also called as thermal decomposition. Okay, so what happens for some compounds, they are gonna break down when they are heated, and that's where we decompose the compound into its original elements. So let's say you have calcium carbonate. So when calcium carbonate is heated, it is gonna get broken down into calcium oxide and carbon dioxide, forming the two original elements. All right. The heating method is typically going to be used for separating out the carbonates or metal compounds. Okay, so the thermal decomposition is typically used to separate the compounds which are carbonates or any metal compounds. All right, second method for separating the elements from compound is electrolysis. So what is electrolysis? Basically, electricity and electrical energy is used to separate the compounds. All right, the example for electrolysis is water. So water can be decomposed into hydrogen and oxygen, the base elements which form water. We use the method of electrolysis. So with the help of electrolysis, water is broken down into hydrogen and oxygen. You have a couple of other examples like molten sodium chloride. So melted sodium chloride, if you are using electrolysis, you can separate out sodium and chlorine from the molten sodium chloride. All right. Typically, electrolysis is a process which is used for water kind of compound, salts, or any other metal extractions. All right. The third process which can be used is chemical reaction. All right. Now, sometimes um, adding a different chemical or adding any other chemical into an existing compound makes the compound break into its original elements, right? So a chemical reaction happens by adding another element and another chemical, right? And it breaks the compound into its individual parent elements. So that is what is the chemical reaction. Let's say for iron oxide plus carbon, if we are adding carbon to iron oxide, it separates out your iron, right? So that iron element is being separated out. So that's an example how chemical reactions can help the compound to break down into its original elements, and it's typically used for extracting the metals. Important thing to remember about separation process for elements is you need to remember compounds cannot be separated by physical methods, right? It can be only separated by the chemical methods like heating, electrolysis, or chemical reactions. So when I say physical methods are like filtering or sieving, because you cannot have those physical methods of, let's say, filtering used when the elements are chemically reacted with each other to form a compound. All right, so that's the key thing to remember. Now let's come to mixture. Now we talked about compounds which are like chemically bonding of two elements. Now what is mixture? Mixture is made when two or more substances are combined without the chemical bonding, right? So the key difference between compound and mixture is compounds are formed with the chemical bonding, mixtures are formed without the chemical bonding of substances. All right, so the substances are going to keep their own properties because there's no chemical bonding had happened. So the original properties of the individual substances in the mixture are going to remain there as is. Mixtures are the one which can be separated physically, right? Because the it is just a mixture, there's no chemical bonding or chemical reaction had happened to create or form a new substance, right? So I can still use physical methods to separate the components or the substances into a mixture. Another important thing that is the difference between a mixture and compound is no new substance is formed in a mixture because there's no chemical reaction, there's no combining of the elements, so no new substance is being formed. While in compound we are getting a new substance. One typical example of mixture is air. All right, so we all know air is a composition of three typical gases, that is your nitrogen, oxygen, argon, and then a small portion which is gonna have a mixture of all other gases, which is like your carbon dioxide or helium or hydrogen and other things in a very small percentage. But basically air is a mixture of various gases together, right? So it's made up of different types of particles mixed together. These particles are nothing but the matter in the form of gas, right? The composition of air varies because based on the regions, the amount of the water vapor that is being there into the air, it makes the composition of air vary. All right, so it is depending on the region or the weather, how much ever water vapor content is there into air, it actually varies the composition of the air. So standardized composition is in this way, like around 78% you'll have nitrogen, 20% oxygen, and then 1 to 0.9 you'll have argon, and then 0.04 percentage would be mixture of all other gases, right? So this is a standardized typical composition of the air. But as I said, based on the water vapor content into a given region or a weather at a given place, the composition of air can vary. All right. So now, as we talked about the separation of compounds to the elements, we are even going to talk about separating the mixtures. All right. Now, as we discussed, in mixtures, there is no chemical bonding happening, there is no chemical reaction happening. So, the elements or the substances which are there into the mixture are going to maintain their own properties, right? So, now mixtures can be separated using physical method. I don't need any chemical process to separate out the mixture, the substances from the mixture, right? I can use physical methods. So the examples are like filtration, your evaporation, sieving, or using magnetism, like using the force of magnet. We can even physically separate out the substances into a mixture. Now let's talk about separating air. As we considered air as a standard and a good example of explaining mixture, let's talk about how air is getting separated, right? So there's a process which is called as fractional distillation of a liquid air. Now this process is used to separate out the various gases from the air, the various gases which formed air, which is eventually a mixture, right? So now fractional distillation of liquid air is actually a physical process, and that is being used to separate out the original contained gases from the air, right? So what we do into this fractional distillation, first thing you have to filter out the air. Obviously in air there would be dust particles and other things, so first thing is we will filter the air to get rid of the dust and dirt, right? Then you get an typical original air mixture with the gases only, as dust and dirt is being removed. Second step, which is like cooling this air. Now the air that is free from dust and dirt is cooled to a very low temperature until it becomes a liquid form, right? So if you recall, we had talked about how to reverse process from solid, liquid, and gases, then gases to liquid, and then solid kind of stuffs, right? So cooling the air at very, very low temperatures converts air in the gas form into liquid form. Now, once we get the liquid air, the third and the last step is this liquid air is warmed again, means a heat is being added to this liquid air, and that results into separating out the gases. Now, heating the liquid air, how it results into separating the gases, because all these elements into the air, right, the different gases, they have their own individual boiling point. So when I let the liquid air boil, the gases will have their individual boiling point, and at that given temperature a particular gas will be separated out, right? So you have nitrogen, oxygen, and argon, right? So nitrogen has the lowest boiling point than argon, then oxygen is having higher boiling point than argon, right? So first nitrogen goes off when we start boiling the liquid air. Nitrogen goes off, then argon goes off at the given temperature, and then once the temperature rises a little more, we are boiling the liquid air a little more, oxygen goes off, right? So that's how fractional distillation works, um, for the liquid air and to separate out the gases, because individual gas has its own boiling point. So when it is being boiled at different temperatures, each gas would start separating out, and that's how we separate air, which is basically a mixture. All right, so that's all we had for today. We have learned more about compounds, then properties of elements and compounds. We have talked about how the chemical names of compounds are formed, what are the rules to form the chemical names of compound. We talk about separating processes for mixtures and compound. All right, so this is pretty much for today's session. I have a quiz added onto the description. Try yourself, let us know how you find it, and do post your comments. Thank you so much for watching.